So we already know about the SVD, and when we create the SVD, it means we are going to reduce the dimension, or we call it, this is the dimensionality reduction. We have 4 items, we have 4 users, so we can just select what will be the dimension that we want to calculate. As you know, at the first time, when we do with the matrix factorization with SVD, we have 4 multiplied by 4, and then we select only the two-dimensional space. So how to select these two? So usually we can just say that the 2 first column and the 2 first column from U and V. But there are many ways to choose which one is the best one. So in this case, I just select 2 among 4 for our calculation. And we can get the dimensionality reduction. So from 4 items, from 4 users, we just select only 2 best options. The matrix factorization, it is a method to generate low rank approximation of matrix. So a low rank approximation of matrix you can see from the U and from the V, and also with the singular value. In this case, we can say that we want to detect the latent factors. So latent means hidden, something that we cannot see clearly in the real value. And we are going to project item and users in the same n-dimensional space. So usually when we do with the matrix factorization with this linear algebra methods, at the end we can do like this. So we can plot into 2-dimensional space. There are some arguments that the prediction quality can decrease. Why? Because we do not consider the original rating. When we do with the linear regression, we transform the value into negative value into the real values. So you can see with this value, we do not understand what is the meaning by minus 0.4. What is the meaning by 0.4? It is not the real rating values. This is from the linear algebra. So we call this is the model in the matrix factorization. So some arguments mention that the prediction quality can decrease because the original ratings are not taken into account. But the prediction quality can increase because we can filter out some noise in the data. So when we transform into the matrix factorization, we transform into a value that is in the particular range. And we can detect the non-trivial correlation in the data. So using the SVD, actually, it is a singular value that we can know the correlation. So depends on the right choice of the amount of data reduction. We need to select the number of singular value in the SVD approach. So the singular value that I showed you before, we have 4 multiplied by 4. But we select only 2 among 4. Parameters can be determined and fine-tuned only based on the experiments in certain domain. So if we look at the movie data, then the parameters maybe only fit to movie data. If you use book data, then the parameter might be only for the book data. So here, there's one paper. He discussed how many factors that can be used to derive from the rating pattern. So in our case, we just select only two factors. So I show you two factors. It is to make it easy for the calculation. But based on this experiment, he mentioned that between 20 until 100 factors is good. So it means we cannot calculate by hand. So we need to calculate by some tools or by the program. Now let's look at the other way to deal with the rating prediction. If you already know about the association rule mining, so I already taught you in the second week. It is commonly used for the shopping behavior analysis. So the aim of this association rule is if a customer purchases beer, then he also buys diaper in 70% of the cases. So you can have some rules. What is the support and what is the confidence? So you already know the algorithm of the association rule means we want to detect some of the association, or we call it items. Let's say X is the item, Y is another item. So I want to know if someone buy beers, what is the probability or what is the confidence that he also buy diapers? And we have a set of transaction. The measure that we usually use is support and confidence. So this is the formula that we already have from the chapter about association rule mining. So you can take a look again based on those slides. Okay. Now let's see with this data. When we do with the association rule mining, there is one that is the categorical value data. Okay. So if we use with the association rule, the data should be categorical. Meanwhile, rating is numerical. Okay. Then, yeah, it depends on how we define the categorical value. So the simple approach is we can transform the 5-point ratings into binary ratings. So if we have the rating 1 until 5, of course it is numeric. So how we can transform this into 0 and 1? There is one way. We can use the mean adjusted average. If you still remember, last week we learned about the mean adjusted average. So if it is above the average, then let's make it 1. If it is lower than the average, let's make it 0. Then 0 is below the average and 1 is above the average. So you can see this one. It is the mean adjusted average of user Alice. This is the mean adjusted average rating on the user 1 and so on. Then we can say if it is above the average, the value will be positive. So if it is positive, the rating is 1. If it is negative or 0, then the rating will be 0. Then this is the result of binary. We have 0 or 1. So if you already look at the data set for the association rule mining, everything will be in 0 and 1. After we have this 0 and 1, then we can calculate, for example, item 1 given, is there any association between item 1 and item 5? Is there any association between item 1 and item 5? So let's say I do not consider Alice. Okay, so without Alice, what is the support? The support is when item 1 is 1, I want to know whether the item 5 is also 1 or not. So the support is 2 divided by 4. So when item 1 is 1, item 5 is 1. Okay, we have 1. When item 1 is 1 and item 5 is 1. Okay, we have another. This is no, this is no, 0. 0 means we do need to consider. And among the values, so we have 4 transactions. And among 4 transactions, there are 2 transactions at item 1 and item 5. Both of them have the rating 1. Okay. So we call this is half of the transaction or 50% of the transaction. They consider that the person who give a good rating on item 1, he also give a good rating on item 5. That's the meaning. And then what about the confidence? So the confidence, if I have the item 1, item 5, it means based on the formula, I will check the item 1 and item 5 divided by the total of item 1 that equals to 1. Okay. So item 1 and item 5, it means I want to know how many of users who give the good rating on item 1 and item 5. So 1, 2. Okay, so they are 2. Divided by the number of users who gave a good rating on item 1. The number of users who gave a good rating on item 1, which is only 2. So it means among the users who give good rating on item 1, and I want to know what is the users who give good rating on item 5. So 100% give good rating on item 5. So when we do with the association rule mining, the basic method is, I want to make a recommendation for Alice. I want to make recommendation for Alice. And we need to determine the relevant rules. The relevant rules means the support and the confidence. The support and the confidence should be higher than some values, or it should be higher than a threshold value. We call this is threshold value. For example, the support should be higher than 0.5 and the confidence should be higher than 0.5. Then if it is higher than 0.5 for both, it means those rules are relevant. So it means, the above rule will be relevant as Alice bought item 1. We need to determine items that not already bought by Alice. So in this case, Alice did not buy item 5. So we want to know whether Alice will buy item 5 or not. So we need to sort the items based on the rule, confidence, values. So this kind of rating, it can be different. For example, you want to know based on the dislike statement. So if you have the dislike statement, yeah, we can also convert this rating. For example, the user association. So I want to know whether user 1 is associated with user 2 and so on. Okay, so there are some variation for this one. So the idea is using the scenario in which association between customers instead of items. So we want to look at the users and then we want to find the item correlation. Let's say if user 1 like an item and user 2 dislike the item, so at least the target user will like a particular item. So this kind of item means we need to calculate based on the support and the confidence. If the score is high, of course, we have a good confidence. If the score is low, then we have a low confidence. So we need to calculate the score. Now let's see. Suppose item 1 and item 4, okay, item 1 and item 4 are chosen to recommend item 5. So we choose the item 1 and item 4 to recommend item 5. So I want to know whether the item 4 and item 4 is good to recommend item 5. And let's determine the threshold 0.7. Okay, so the threshold, in this case, I want to put the threshold for the score. Based on the formula, score is the multiplication between support and confidence. So we need to calculate the support first, and then we need to calculate confidence. And then after we have the value, we do the summation. We do the sigma. Now, let's look at the first one. This will be the support for item 1. This will be the confidence for item 1. This is the support for item 4, and this will be the confidence for item 4. Now, let's take a look. The support of item 1. In this case, I have the I1, whether it is associated to item 5. Based on the previous calculation, we can see there are 2, okay, among 4 transactions. Then the support is 2 divided by 4. The confidence among the 2 users who like item 1, both of them also like item 5. Then we have this one, 2 divided by 2. What about item 4? Item 4, there are 2 among 4 transactions. Then the support is 2 divided by 4. What is the confidence? Among the 2 users who like item 4, 2 of them also like item 5. Okay, so the confidence is 2 divided by 2. Then we can see this one, half multiplied by 1. So it is half, and half multiplied by 1. So half. Then the score is 1. So if we have the threshold, okay, so it depends on the threshold definition. You can have, let's say, the threshold for the score, or you can have the threshold for the support, or you can have the threshold for the confidence. But usually we have the threshold for the score. The score is higher than 0.7, then we say that, okay, we can use item 1 and item 4 to recommend item 5. Because the value is higher than 0.7, then we can say that Alice will like item 5. So that's how we can say about the result. Now, we already look at the confidence. So this is the confidence actually. This is the confidence from item 1 and item 5. This is the confidence from item 4 and item 5. Now, what is the confidence of item 3 if it is chosen to recommend item 5? Item 3 to recommend item 5. What is the confidence? Maybe for the support. What is the support? The support is just only we have two. Okay, the two item. This one, the support of when the users like item 3 and the users also like item 5, there is only one. And among the 4 transactions. Okay, so this is the support. What is the confidence? The confidence, item 3, the user 2 like item 3 and he also like item 5. The user 4 like item 3, but okay, he doesn't like item 5. Then among the count of user, among the count of item 3, it means there are 2 from item 3. How many of item 3 and item 5? How many of them that like item 3 and item 5? It means we have only 1. Okay. So there are 2 item 3, which is 1, but among those 2, only 1 that is 1 and 1 for the item 3 and item 5. Then we got the confidence is 1/2 or 50%. Okay, let's have a break. Okay, I will continue after the break.